This is a graphical representation of the projects that are inside SafeGuard Profiler. So all the elements that interact between them and how do we put them together. The user puts them together. So here's the project, and from the project we open a project and it is empty, and then from that project the first thing that we try to do is either import the HAZOP and then start constructing all the LOPA scenarios, or we go ahead immediately start building up those LOPA scenarios in manually without any input from the HAZOP imported from an imported HAZOP. But the normal way to do it would be to open up a project, import a HAZOP file, and in that HAZOP file you go through the HAZOP file and then search all the scenarios for scenarios that end up having the same consequence and also having the same area, for example, as a criteria in the same area of interest with the same consequence. So we regroup all those scenarios, HAZOP scenarios, in what is called the LOPA scenario, or that is going to be created for the first time as a master scenario. And you go through the HAZOP in the same way, looking for a different consequence. Then you will end up with the LOPA scenario number 2, and so on until you have all the layer protection analysis scenarios. Once that layer protection analysis scenario it is created, either manually or by importing it or creating it through the HAZOP file, then we end up with this LOPA scenario, which is made up of initiated events or event causes, and then we have the safeguards associated with those causes, that if they're not if those events are not stopped or they are not mitigated by the safeguards, independent protection layers, they will end up in the unwanted event or hazardous event. So here we have a representation of all these initiated events and independent protection layers. They could be input by manually. That's the M. What it means, the M is a manual input of the probability of failure on demand of each independent protection layer. And for the one special safety implemented function safeguard, if it is required, then we will put we can later on link it, and then we can jump to it directly. So the user here will create a safety implemented function loop or scenario, again a master, in the case that one was required after the analysis here in this LOPA scenario master. Once this safety implemented function it is created, then later on can be linked to that specific safeguard. For example, this is an arrow that shows the linking of this independent protection layer number 3. It is linked to safety implemented function 102, which is now the software links it directly. So when you modify the probability of failure on demand of this safety implemented function by doing the SIF verification part, then automatically will update in your LOPA scenario, telling you if you still have a gap or you are in target, and so on. It allows you to do that that part of the facility, part of the modeling, right? So next we have the safety implemented function that is manually created. So you create that safety implemented function, and a safety implemented function, for example, safety implemented function 102 or 103. So in this case, in a safety implemented system, you might have more than one safety implemented function. You might have, for example, the loop number 102, and which is independent protection layer 3, as we saw before, and we can have linked to that section, to that layer protection analysis loop. So, but that doesn't mean that you might have another loop, and that other loop might be, for example, independent protection layer number 6 that is being used someplace else, and it is defined by the safety implemented function loop number name loop 103. So in this case, again, this is the way that is related to layer protection analysis related to safety implemented function. Again, things to pay attention is what we call LOPA loops or LOPA scenarios, coming from the regrouping of from the hazard of having the same consequence. Later on, we have then a different type of loop, which is the safety implemented function loop, or master safety implemented function loop in this case. So we have encircled in red what we call layer protection analysis loop, and what we have encircled in blue is the safety implemented function. And this we can see that they are linked, and we can link a loop. That's what we later on will talk about. How do we link a safety implemented function to a layer protection analysis scenario, right? So again, trying to make a connection between what is behind the scenes in SafeGuard Profiler and what you see. So we have the project, so that's your project. The project name appears there with the documentation title for that project. That's done in the first select project screen. Then you have a scenario and deviation that you describe here in the description. So here you will see here the loop type. This is a layer protection analysis tube type. We are in the event page. That's important to notice. That will let us know what type of loop we are working with. And also here on top we'll see that the software indicates what type of loop are we working on, if we're working in a layer protection analysis scenario or if you are working in a safety implemented function loop. Then we also have the name of the loop. Here this is very important, and we'll talk a little bit more about that name in later slides that are coming in or later. And we have also here the total amount of loops, and this will be loop number 1 out of 92, for example. So this is important information that you can see there described, that we can make reference to the previous 2 slides that talk about the modules that exist or the elements that exist inside SafeGuard profilers and how they are related to each other. So this will be still in the layer protection analysis loop. You can see here that circle that says the loop type, and we are now on the second tab, or the second page we can say. So we were in the event 1 page, now we are in event in the seal determination page, which is page 2, and there we have here the initiated events or causes that we were talking about before, and each cause how is related to a specific independent protection layer, right? So we can see here the probability of failure on demand of each safeguard. And here in this case we can see that they were all inputted manual. So this probability of failure on demand was given manually. Someone had to go in there and type that 0.1 value in there. Again, the name is important to notice, and we can see here now that this is loop number 74 out of 92, and that is inside SafeGuard Profiler, and these 92 modules total that are in there includes safety implemented function loops and LOPA loops, or layer protection analysis loops. So again, so SafeGuard Profiler, when we talk about the loops, and also this is to describe this amount of 13 out of 20 loops, or sample description of what that means. So again, we have your project, and then we have a graphical representation, and we can see that loop designation names or the layer protection analysis names, they must be unique. And anyways, the software would present a screen telling you that the name has to be unique if you try to put the same name twice. So we can see here the same representation as we had before, the initiated events. We have the independent protection layers, and we have this independent protection layer number 3 is a safety implemented function which is linked to safety implemented function 102, for example. And so that's what we call the loop link. So we're linking 2 loops together. So And it is important to notice that inside SafeGuard Profiler you have all these loops that we were talking about. For example, in this case 20. So we have 20 loops, and the loop that we're looking at this moment will be loop number 13. So loop number 13, this is 13 out of 20. Loop number 13, it is in this case is a blue loop in there. So in the initiated event 4 or initiated event 1, it is linked or has a safeguard in the independent protection layer 1, that is number 3 here, right? So it's linked to safety implemented function 102. That will be the third independent protection layers 1, 2, and 3. So again, this would be a graphical representation of your project. Again, we have to be careful that loop designation names must be unique, whether they are your LOPA loops or safety implemented function loops. They are all together inside SafeGuard Profiler in no specific order. So as soon as they appear, as soon as you create them, they become available. So this order is not necessarily we don't have any influence. It's the software that is taking care of their regrouping or reordering of these modules or instances of layer protection analysis and instances of safety implemented functions. So we can see here in this case that we have 13 out of 20 loops. The loop number 13 will be that one that is presented there. So scenario, loop number 13, LOPA name, its name, unique, LOPA 13, and again as I initiated event 1 with IPL 1 independent protection layer, and is the third protection layer, which is linked to SIF 102. So that was a representation of the internals, or a graphical representation of the internals of SafeGuard Profiler. Now we're going to continue with section number 2. We're going to create some layer protection analysis loops, and we will watch some videos made already, so that will be easy to see. Then we will go through seal determination, what is an example of a LOPA scenario analysis. We will do Butane Sphere, that is coming next, and I will go through that scenario, and I will solve it first in a methodology which is layer protection analysis, and later on I will solve the same scenario using risk graph methodology or risk graph technique. And at the same time, in both places, there is going to be also other videos with respect to creating different scenarios, or what we call alternate scenarios of each master scenario that was created before. Then we will work with the safety implemented function loops verification. That means working with reliability block diagrams and how to create that with SafeGuard Profiler, to come up with the probability of failure on demand are all the factors that affect each element using a safety implemented function loop. And then we also will go through other videos with respect to loop optimization. There's radio buttons that when you click on them will tell you exactly how to optimize your reliability block diagram or your safety implemented function with respect to values or factors that affect the probability of failure of demand, or that will affect the architecture, so it will affect the voting system. But we will look at that later on. So at the moment what we're going to go through is an example, a Butane Sphere example, and there's a certain situation. I'm just going to read it and explain what that situation is, and then from there we're going to analyze this situation using the layer protection analysis method, and then later on, as I said before, the risk graph. So this is a simplified probability failure PNID, a simplified piping an instrumentation diagram of a simple butane sphere. So we can see here there's a manual inlet with product. Then there is a level controller of the butane sphere inside that is controlling this level valve. And also we have steam coming in to temperature, depending on temperature. So in order to keep the butane or the LPG temperature constant. And then we have here the manual outlet valve for the trucker. There's a trucking out activity that goes on. So there's people come in with the trucks and to load product in. So they have to manually operate the valves and pumps, loading pumps. So this is a typical old butane sphere park, or this is one unit that repeats maybe 5 or 6 times. So and there's a specific scenario happening here. So is say this facility experienced its first uncontrolled release since it was built 30 years ago. So you can expect that this facility is kind of not new. So let's see what happens.